Hi all, welcome back to my channel. Hope everyone is doing fine. Hope everyone have completed their respective task regarding studies for today or studying right now. So this is day 112 of my GATE CS prep journey, and today I've studied exactly of 11 hours. I've just completed my day regarding studies. So I've studied today algorithm, digital logic, and CN, revision of CN. So I have started my day with digital logic. Like I left half lecture yesterday, so I completed first that and then I went to next lecture for today. It was regarding combinational circuit on encoder and decoder. With notes, I have made that, and then after that algorithm recurrence relation, it was at like it took time, of course, because again going in very depth and writing everything, so it took a lot of time today for one lecture, like second lecture of recurrence relation, but it's fine. I understood everything. And regarding CN, I was revising like sliding window protocol, go back and selective repeated their formulas, questions based on that. uh, I've done very little bit of CN, but I did, like I'm ending my day, so remaining I'll do tomorrow. So if I have to show you what I've studied, right, I'll show you with the notes. Starting with digital logic, you can see, just give me a sec. This is for yesterday's. Mux is universal logic. Have you guys heard this? I mean, this is the fact I got to know. This were important Mux problem. I think this was covered yesterday only. So yes, encoder, decoder, and this is the combinational. So what is encoder? Any type of code into binary code is encoder. So everything regarding encoder, like truth table, then symbol, and what are limitations of encoder, which are like if more than one input is active, then output is unpredictable. And solution for this is priority encoder. So output will be decided according to which highest input line is high. No way to detect if no input is active. There would be like one pin which is called active high low pin, enable pin, you can see. So if output of pin is 1, then it will work. If it is not, it won't work. Designing of, then there was like part to design encoder based on the requirement 4x2 encoder. Then there are a few steps you need to follow, like first is identify input and output, then truth table, then expression, and if it is not minimized, you can minimize it. Hardware implementation, I mean, not important according to gate, but still we should be knowing it. And there is optimized implementation for it. So this priority encoder was there. And step 4, this is expression. Optimized solution is same as normal encoder only. Then there is 8x3 encoder we need to design. So I have designed, I mean, not I have, in class only we have designed it. You can see for like 8:3, right, from 0 to 7 it would be there combination. So for 0, 1 present, 1, 2, 3, for each till 7 1 would be there, and which is very common, like binary thing, you can see. According to that, you need to make the expressions. Here if you see for I0 1 is there, so I1 will come, and like that you need to see where 1 is there and just make the expression and then symbol. So encoder are practically used in priority switches. That is the practical application of encoder, you can see. And then there is decoder, which is used to convert binary code into any other code. Is decoder. This is combinational circuit, convert n-bit input binary into 2 raised to n unique output lines. Then this is symbol. We need to design again. 2x4 decoder. Truth table symbol. E is 1 here. Then these were few questions. 3x8 by 2x4 decoder. So here using decoder we are giving not. So that's why again third encoder like decoder is used. And here also like big kind of 4x16 using 2x4. There is trick, like you need to keep dividing until you get 1. You can see here to design 5x32 decoder using 2x4. You just need to divide 32 by 4 until you get 1, and then you need to add it, which is 11. So same trick you can apply to design a decoder, like big number of decoder using small. Just keep dividing until you get 1 and then add it. So that was a digital logic for today. Like 1.5 lecture only I've covered. I need to complete it like second also, but then algorithm lecture took a lot of time actually, so I could not go for any other lecture for digital logics. Coming back to algorithms, let me tell you. Recurrence relation is going on, like from where I've see here. You need to find stack space, how much stack space it takes. Depth. So depth is root to leaf longest path. So you can calculate depth based on the longest leaf path by expanding it. So this is the longest leaf path, and you just need to see how many total number of levels are there, and then space complexity you can calculate based on that. Space complexity of recursive function is depth of recursion into space of each function call. So that's a conclusion of space complexity. Here like there are example only what is space complexity for below recursive function. You need to find using recursion tree. So here what is happening inside code, like n is getting decreased by 1 until f of 1 when you draw the recursion tree, and space complexity also. So here like space complexity is depth into space for activation record. Okay, so depth is number of function call or level, and the space for activation record is whenever some function get called, it needs some space, like activation record needs some constant space, that is C. So a lot of different parameter includes in activation record, like 7 to 8, and out of that this formal parameter and local variable we need to check in this R code, because in function n is formal parameters, so that is being used. And what else? So only formal parameters is there, and which is also n, and constant you can consider as C. Again this is example, you can see this is example. So 0, 1, 2, 3, these are levels. K plus 1, and to find the total number between is you need to use the formula for consecutive number, like last minus first plus 1 to get the total numbers. what is it? Then this is again this example only. You can see here I have drawn recursion tree. Total n number we have find, so total number of levels are n only, and number of levels only depth. Depth is n function call, and when function call executed, activation record pushed into stack, and it will consume some space. So again I'm reporting the space complexity formula only. So again this is again different example. Inside recurrence of n, this again getting called twice, n divided by 3 to n by 3. So this is pattern for power 0 0 level, power 1 1 first level, second level, third level. So this is the pattern you can observe also. Then there was different topic in this, analyzing time complexity. Now space complexity is done till here, but now time complexity. So this is the total number of function calls, and C is for that activation record. Whenever it is going to push into stack, it will take some constant space, so C is for that. Depth is n function call, need to find TC. So time complexity does not depend on depth of the function call, and I think there is proof also. Here you can see from this diagram you cannot find how many number of function call has happened. So this is not like they have given the proof. As we can see, it's not feasible to always count number of function to analyze time complexity. So we must use some other way to analyze time complexity of recursive function. And what is that? So basically find recurrence equation corresponding to the recursion function, and then we solve that equation and get time complexity. So there is recurrence equation we need to form and solve it instead of this tree, because it's not feasible. So just calculate, if I explain the simple example here, for fact of n it will take t of n time complexity. So since inside fact of n only n minus 1 is getting called, so if for fact of n t of n is taking time, then for fact of n minus 1 similarly it will take t of n minus 1 time. And for constant, like for functions like comparison, like n equal to 0 or n equal to 1, it will take constant time. Multiplication, each equation still incomplete because there is a terminating condition, which is this if n equal to 0 or 1, and for that also it will take constant time only. So C, you can see this is the final equation, like t of n equal to C if n is less than or equal to 1, and t of n plus 1 otherwise. This is the recurrence equation we need to find corresponding recursion function. Just allow me a second. These are like similarly example. I'm just trying to find the explanation. For fib and t of n, C when equal to 0, again comparison for C. Then n minus 1, t n of like minus 1 minus 2. And you can see for t of n, C for this comparison, and t of n minus 1 plus t of n minus 2 plus C otherwise. So t of n is for fib of n, and t of n minus 1 is for this 2, and this is the middle constant thing. So line by line it comes into equation also. I think all these examples were there for recurrence relation. This is equation because tree is not feasible. I think I've repeated myself. So this is for algorithm that I've covered. Like you can see, I've written each and every line explanation. That's why it takes a lot of time, but it's fine. It's understanding also important, so I have done that. There was some, I think, okay, I think, yeah. Let's see the dashboard. If I have to do any progress mark here, what regarding CN, I have already, I think, for sliding window protocol, I have revised formula and solved questions on my own. But topic is not completed for today's. You can see here. Where is digital logic? It's not coming here, I feel. The topic I've completed is not coming here. Okay, fine. There is nothing to mark then till now because I'm just covering the lecture and regarding the topic thing. So if I see I am here only, but this is not completed, so I am not going to mark it as completed. But some part is completed, but I'll mark as done once I'm completely done with these topics. So that has been my day today. So let me know how many hours you guys have studied today, how much content you have covered, what you have studied. That also you can comment me down. And if you also want to be consistent like me, like studying 10 to, I've exactly studied 11 hours today, including all this content I have shared. So if you also want to be studying like this till gate exam gets over, stay along, follow along my channel, and please do subscribe. Thank you all for joining and watching my videos, and most importantly, I think, showing up every day for studies. So thank you all.